Hi guys, welcome to today's class. Today we start with a new chapter on logarithmic expressions and then we move on to logarithmic equations. The general form of a logarithmic expression is as follows. L of x, L is a name, you can put anything instead of L, is equal to the log base b of x. This is how you read a logarithmic expression. Log base b of x. Now as you can see here, we have two numbers. One is x, which is the variable of course, and one is b, which we call as base. Now b should be a positive number but not equal to 1. Now we see b must be a positive number but it cannot be. X is taking only positive values. Log base 2 of x, log base 10 of x, and remember that log base 10 is called decimal logarithm. Exponential and logarithm expressions are opposite expressions in the sense that if y is equal to log base b of x, then x is equal to b to the power of y. For instance, we say that 2 is equal to the log base 10 of 100. Why? Because 10, this base, to the power of this 2 gives us this 100. There are some basic logarithmic rules that helps us in order to solve logarithmic equations. First rule is that the log of base b of b is equal to 1. That means the logarithm of the number in its base is equal to 1. For instance, log base 2 of 2 is equal to 1. Log base 12 of 12 is equal to 1. Next, log base b of x to the power n. You see here guys, x has the power n. What we do with this n moves at the front of the logarithm like this is equal to n times the log base b of x. What we have done is, actually we have moved this power from the x and at the front of the logarithm. For instance, log base 3 of 9 is equal to log base 3 of, we can write 9 as 3 squared, which is equal to, now what we do is we move this 2, which is the power of 3, at the front of the logarithm. 2 times log base 3 of 3, and using the first rule, the log base 3 of 3 is equal to 1, that's 2 times 1 is equal to 2. The third rule which we use here is when the power is at the base, that is log base b to the power m of x. Now still we can move this power at the front of the logarithm, but this time we have to reverse it. We write it as 1 over m log base b of x. Remember guys, the difference between this rule and this rule is here, that here the power is for x, we move it at the front of the logarithm as it is, but here the power is for the base, here we move this power still at the front of the logarithm, but this time we reverse it. For instance, log base 4 of 2. We can write this 4, which is the base actually, as 2 squared. Log 2 squared of 2. Now what we do, we move this 2 at the front of 1 over 2 log base 2 of 2. Now we know from the first property that this is 1, hence we get 1 over 2 times 1 is equal to 1 over 2. It's very important to remember the relationship between exponential expression and a logarithmic expression. We said that y is equal to the log base b of x if x, this x, is equal to this base, this to the power. Now guys, what happens is the base for the logarithm and for the exponential expression remains the same. What changes is the location of x and y. We say that y is equal to log base b of x implies that x is equal to, this guy is equal to b to the power of y, right? Let me give you an example. We say that 2 is equal to the log of 16/4. Why it's the case? Why? Because we can write 16 as 4 squared, right? So guys, still I emphasize that this base here in the logarithm is still the base for the exponential expression, right? Let me give you one example. Test whether 3 is equal to the log of 12 in the base of 2. Check it. Now we say that this is true only if 12 is equal to 2 in the power of 3. Now let's see, still question mark, is it true or not? Let's see. 2 to the power 3 is 8. And we know that 8 is not equal to 12. No. Hence, we say that 3 is not equal to the log of 12 in the base of 2. Right? Okay, please remember guys this rule. Okay, the first property of the logarithm was saying that if you have base and the number the same, you get equal to 1. Right? For instance, log of 10 in the base of 10 is equal to 1. Log of 12 in the base of 12 is equal to 1. Log of 10 in the base of 10 is equal to 1, and so on and so forth. This was the first property of the logarithm. The second property, we studied that if you have a power here, x to the power n in the base of b is equal to what? N log x in the base of b. What we do here is we move this n at the front of the logarithm, right? For instance, if you have logarithm of 100 in the base of 10, if you have log base 10 of 100, what you can do is you can write 100 as 10 squared, base is remaining the same. Now using the second property, we can move this 2 at the front. It becomes 10 and 10 here. Now you know from the first property that this is 1, this is 2 times 1 is equal to 2. Hence, what we can do is we can write that the log of base 10 of 100 is equal to what? Is equal to 2. Likewise, the log of base of 1/2 of 1/8 is equal to log 1/8. We can write 1/2 to the power of 3. 1/2 in the base remains the same. Now we move this power at the front of the logarithm. This becomes 3 times log 1/2 here, 1/2 here. Now using the first property, we can say that this is 1. Actually, this is 3 times 1 is equal to what? Is equal to 2. The third property is kind of similar to the second property, with the difference that we have the power this time on the base. Log base b to the power m of x. Here still we can move this power at the front, but this time we reverse it. Log x base b. Okay, for instance, if we have 4 and 16 here this time, it's equal to the logarithm of 4. How we can write 16? We can write 16 as 4 squared. Now you see that the power at the base is 2. Now what this means, we can move, using the second property, you can move this power at the front, but this time we have to reverse it. 1/2, the log base 4 of 4. Using the first property, this is 1. This is 1/2 times 1 is equal to 1/2. Okay, therefore you can write that the log base 16 of 4 is equal to what? 1/2. Furthermore, if you have something like 100 and 1000, now you can write both 100 and 1000 as the bases of 10, as the in the base of 10. You can write both 1100 in the base of 10 as 10 to the power 3 and 10 to the power 2. Now you can see here we have a combination of the second property and the third property. We have the power here for the number itself at the front of the logarithm. We also have a power in the base. What we do, we step by step move both of them at the front. First, let's move 3 at the front. 3 remains the same. This here again 10 squared. Okay, now this time let's move this 2 at the front. What comes out is equal to 3. Now you know when we move this 2 from the base, we reverse it. 1/2 times the log of base 10 of 10. Now from the first property, we know that this is 1. This is equal to, as a result, 3 times 1/2 times 1, which is 3/2.